let's take a look at a few more problems involving sum and difference formulas for cosine and sine, and then we're going to introduce the one for tangent. So we learned previously how to compose inverses. And one of the compositions was when the trig functions were different and the inverse was on the inside. This was actually type 4. So if you need to rewatch that video, you can also do that. Composition of inverses type 4. So how we did this is that we assigned an angle to the inverse, which again, you could do smiley face, but I'll do theta. And then what this tells you is that the cosine inverse of 3/4 is equal to theta, which means that the cosine of theta is equal to 3/4. Knowing that, you could draw a triangle adjacent over hypotenuse. So 16 minus 9 is going to be the square root of 7. Now the tricky part about that, which again I'm going to repeat, is the quadrant, which a lot of people forget. Triangle, quadrant, they go together. So the way that we find the quadrant is where you created the inverse. So cosine inverse is restricted from 0 to pi. But because this ratio is a positive ratio, it's going to be in quadrant 1. Because in quadrant 2, cosine is negative. So you are in quadrant 1. And then what you do is you look at the outside function, which was cotangent. So I have the cotangent of theta, and that's going to be adjacent over opposite. Quadrant 1 is positive, so it's going to be 3 over the square root of 7, or rationalize 3 square root of 7 over 7. So now what we're going to do, and the reason I wanted to review this is because we're going to take this and we're going to combine it with the sum and difference formulas. So if you take a look, this is a composition. So this part is the inside, and this part is the outside. So what we're going to do first is we're going to look at the inside, because anytime you do compositions, you do inside out. So instead of being up here where there was only one trig function on the inside, now we have 2 functions on the inside. So we need 2 angles. So step number 1, assign an angle to the inverse. So because there's 2 of them, I'm going to call this one alpha and I'm going to call this one beta. And when I replace it, I get the cosine of alpha plus beta. Now, step number 2 is something we talked about in the previous video. If something depends on the formula, we write the formula. So we have the cosine of alpha, cosine of beta, minus sine alpha, sine beta. So which one do we have? We only have sine alpha. That's it. So I have 1 ratio, I need 3 ratios that are missing. So you work with alpha and beta separately. So let's do alpha first. So I have the sine inverse of 2/3 is equal to alpha, which means that the sine of alpha is 2/3. So I can draw my triangle. Here's alpha. Opposite over hypotenuse. So 9 minus 4 will give me the square root of 5. Now sine inverse is restricted from negative pi over 2 to pi over 2. That's your output. And because 2/3 is positive, it's going to be in quadrant 1 because sine in quadrant 4 is negative. So that gives me the cosine of alpha is a positive square root of 5 over 3. Okay, now I'm going to look at beta. So I have tangent inverse of negative 3/4 is equal to beta, which means that the tangent of beta is a negative 3/4. Okay, I can draw my triangle. Here's beta, opposite over adjacent. The hypotenuse will be 5. Tangent inverse has the same restriction almost as sine, except it doesn't include the axis angles. But because this is a negative ratio, it's going to have to be quadrant 4. Because quadrant 4 is where tangent is negative, quadrant 1, tangent is positive. So I am in quadrant 4. Knowing the triangle and knowing the quadrant, I can find sine and cosine. So the sine of beta is going to be a negative 3/5. And the cosine of beta is going to be a positive 4/5. Because sine is negative in quadrant 4 and cosine is positive. And now I have all 4 of my ratios. this one, this one, this one, and this one. So now I just plug in. So cosine alpha is square root of 5 over 3. Cosine beta is 4/5. Sine alpha is 2/3. Sine beta is negative 3/5. So this gives me 4 square root of 5. A negative and a negative makes a positive 6. They're both over 15. I can combine them into a single denominator. 4 square root of 5 plus 6 over 15. And again, I cannot combine because 6 does not have a square root of 5, so they're not like terms. Okay, let's look at tangent. So tangent has sum and difference formulas too. Tangent will have a numerator and a denominator, which is different than the sine and cosine. So a few things to help you remember. In the numerator, they're separated, the alpha and the beta. In the denominator, they're together. If it's the sum formula, the plus goes in the bottom, the minus goes at the plus goes at the top, the minus goes in the bottom. And if it's the difference formula, the minus goes in the top and the plus goes at the bottom. So again, just a few things. Everybody likes to remember things differently, but this is just what helps me. So we want to find the exact value. This is similar to an example we had done in the previous video. They're giving it to you in expanded form. So what this is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. A bit hard to see if you didn't know the formula. If you didn't know the formula, you would have no idea. But once you have the formula memorized, then you can recognize. So 15 degrees is alpha, 30 degrees is beta. So this is equal to the sum formula of tangent. So I'm going to replace the angles. I have the tangent of 15 degrees plus 30 degrees. This is equal to the tangent of 45, which is equal to 1. There we go. Again, so in this question is really knowing that it was the formula that was represented there. Let's do one more. Let's do a similar one that we had done previously, but with cosine. So we're given something about alpha. We're giving something about beta. We want to find tangent of alpha minus beta. Step number 1. Maybe you're thinking in your head, hopefully. We write the formula. We need to see. Don't start drawing the triangles before you know if you need them. So this is going to be tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Okay, so I have tangent beta, but I don't have tangent alpha. So I'm going to look at alpha. I know that the cosine of alpha is 1/3. Alpha is between 0 and pi over 2, so I am in quadrant 1. I draw my triangle. 1 over 3. 9 minus 1 will give us the square root of 8, which is 2 radical 2. So the tangent of alpha will be 2 radical 2. And then I already know that the tangent of beta is a negative 5. It's in quadrant 2, so I can plug in. So I have 2 square root of 2 minus a negative 5 over 1 plus 2 square root of 2 times a negative 5. So in the top, I'm going to get 2 square root of 2 plus 5 over, in the bottom, I'm going to get 1 minus 10 square root of 2. So we need to rationalize the denominator. The way that we do that is we multiply by the conjugate, in case you haven't taken algebra in a while. So we do 1 plus 10 square root of 2. It's the same thing we were doing when we were doing identities. Same concept, conjugates. So we foil. We need to foil the top and we need to foil the bottom. So I'm going to do the top first. So in the top, I'm going to distribute the 2 radical 2. So I get 2 square root of 2 plus, and I'm going to write this out just so that nobody gets confused. And then I'm going to distribute the 5. 5 times 1 is 5, and then 50 square root of 2. And in the bottom, I'm going to have 1 times 1 minus, or I'm going to first distribute the 1, 10 square root of 2. Then a minus 10 square root of 2. Then a minus 10 square root of 2 times 10 square root of 2. So in the bottom, the 10 square root of 2's cancel out because one is positive and one is negative. This is why it rationalizes. So in the top, I get 2 square root of 2 plus, so 2 radical 2 becomes a 2. So I have 2 times 10, which will be 40, plus 5, plus 50 square root of 2. And in the bottom, I have 1 minus, and then again, this is 2. So 10 times 10 is 100, times 2 is 200. In the top, I'll combine like terms. I get 52 square root of 2 plus 45. And in the bottom, I get negative 199. So this is how you rationalize, and this is how you will see it in your homework, that you will have to rationalize. So I wanted to do one of them with you in case, like I said, you haven't seen this in algebra in a little while.